Today let's talk about the polygon interior angles. Polygon interior angles. We will apply triangle properties to hypothesize a polygon sum conjecture using polygons, protractors, notes, and class discussion. The number of sides of a polygon. If I have 3 sides of a polygon, then I have 180 degrees. If I have 4 sides of a polygon, then I have 360 degrees. If I have 5 sides of a polygon, I get 540. And 6, I get 720. And then I get 900. And then I get 1080. The sum of the measures of the 4 interior angles of any quadrilateral is 360. The sum of the measures of the 5 interior angles of any pentagon is 540. If a polygon has n sides, it's called an n-gon. So for instance, if I have a 13-sided figure, then I call it a 13-gon. The sum of the measures of interior angles, we know that 4-sided figure is going to have 360, and that means each interior angle is 90. Then I had 540, and each interior angle is 108. I had 720, and each one will be 120. I had 900, each one will have that, and this, and that. Where am I getting these numbers from? Watch what happens. If I take 180, divide by 3, I get 60. If I take 360 and divide by 4, I get 90. See what's happening? I took the sum of the measure of interior angles and I divided by the number of sides, just like I did here. What's the difference here? I go 180, that's plus 180, and 180, and 180, and 180. This is just plus 1, plus 1, plus 1, plus 1, right? What do you think 180 means? What do you think that even talks about? 180 degrees. Well, wasn't there a polygon where all the angles added up to 180 degrees? Yep, a triangle. So the sum of measures of an interior angles of an n-gon is the number of triangles I get times 180. Watch what happens. This is a triangle that has 3 sides, 1 triangle. This is a quadrilateral. It has 4 sides. How many triangles do you think are going to be in here? Watch what happens. I take this, I go diagonal, and now I have 2 triangles. Here I have a pentagon. That's 1. Oh, this is going to be bad. 2, 3, 4, 5. 5-sided figure. I'm going to connect my diagonals, and I get 1, 2, 3. So how did I get from 3 to 1? Minus 2. How did I get from 4 to 2? Minus 2. 5 minus 3, minus 2. So I take the number of sides, minus 2, and I get the number of triangles, right? If I know the number of triangles, and I know each triangle has 180 degrees, then I can figure out that the sum of all the angles in this figure comes from this equation. So let's see, I have to find the angle A, and I know this is 90. Well, if I know the exterior angle is 90, the interior angle is 90, well, 72 plus 90 plus 76 plus A gives me, what in the world would it equal to? Remember, I have a four-sided figure, 4 minus 2 times each triangle has 180 degrees. 4 minus 2 is 2 times 180, and I get 360. So all of this is going to equal 360. Then I do some math, and really all I have to do is solve for A. So the sum of the interior angles of an 47gon. That's my next question. If I have 47 sides, I have to do what to find the number of triangles? That's the number of triangles, multiply it by 180, and I get the sum. Here I have two congruent angles. I have an interior angle here I can find, and an interior angle here I can find. 180 minus 70 gives me 110, so that's 110. And then 180 minus 68 gives me 112. Now I have to figure out these two, right? So I take 110, add 110, add 116, add 112, and I add two of these angles. Each one is B. So what would they all add up to? 1, 2, 3, 4, 5, 6. That's a six-sided figure. Take away 2. Multiply it times 180. 6 minus 2 is 4 times 180. That is 720. So this is 720. This is how I set it up. If you can get this far, you're doing really, really good. So what I want to do is go through this again, and if I know how many sides does a regular polygon have, each interior angle measures 156. So I know that I have an equation that looks like this. The number of triangles inside my polygon times 180 divided by the number of sides gives me each interior angle, which I know is 156. So now I have an algebra problem. I multiply n by both sides. I get n minus 2 times 180 gives me 156n. I divide both sides by 180. I get that n minus 2 is equal to 156 divided by 180 is 0.867 n. Then I subtract 0.867 n from both sides. That goes away. N, well, 1 minus 0.867 is 0.13. 0.13 n is equal to, I want to move this 2 over, so that'll be a positive 2, and now I just take both sides, divide by 0.13, so n is equal to 15. This is a 15-sided figure, so it is called a 15-gon.